if we try to go back to the lecture on rectilinear motion, s of t represents the position function. But if you get the derivative of this s of t, so that is with respect to t, it will provide us the velocity function, okay? And that is s prime of t, representing also the velocity function. But if we get the derivative of the velocity function, v of t, which is v of t is also represented by s prime of t, because that is the derivative of the position function, gives us the acceleration function. So you might as well notice that from s of t becomes s prime of t, then you get the derivative again of s prime of t, giving us the acceleration function. How do you call this one, and how do we formalize the definition of this? Okay, so we call this one as the higher order derivatives. So it means to say that if the derivative f prime of a function f is itself differentiable, then the derivative of f prime is called the second derivative of f. So kapag dinifferentiate mo pa ang f prime, okay, na ang f prime ay ang first derivative ng f, tatawagin mo na siyang pangalawang derivative or second derivative, which usually denoted by f double prime. Okay, and we can continue to obtain the third derivative. So ang third derivative na to ay ang pangatlong derivative ng f. Pero ang third derivative, tinatawag mo siyang first derivative ni f double prime or ni second derivative. So can you see the sequence there? And the fourth derivative, which is denoted by f raised to, well, that is not exponent, that symbolizes the fourth derivative, okay? Kasi hindi ka na pwede maglagay ng apat na prime o apat na symbol na tulad nito. You don't need to have it. And even higher, as long as, okay, there is condition for as long as we have differentiability. So pag hindi na siya pwedeng i-differentiable o paulit-ulit na, let's say nag-end ka na sa 0 at laging 0 na, then it's good as that way. Okay, and when you say differentiability, as we go back, when that is no longer differentiable to any value x, then you don't need to differentiate because it's not differentiable. So the nth derivative of the function f, denoted by f, okay, it seems like an exponent, but that's not an exponent, so that is enclosed n, is the derivative of n minus nth derivative of f. Okay, eh, sabi nga natin kanina, kapag kinuha mo, dinifferentiate mo ang second derivative, bibigyan kaya ng third derivative. Ang pagkakaintindi dito is, itong third derivative ay ang first derivative ng second derivative of f. So from f, kinuha mo ang second derivative, bibigyan kanya ng f double prime. Ang f double prime, differentiate mo ulit, bibigyan ka ng third derivative. Pero ang pagkakaintindi sa third derivative, it's itself third derivative of function f, but that is understood as well as the first derivative of the second derivative of f. So let's know more about this. So here are the following remarks. So ito ang mga dapat nating itindihin. Ang n dito is the order of derivatives. So kapag nakita mo ganyan, it means to say that it's the third derivative. If you see that way, it's the fifth derivative, okay? The derivative of function f is sometimes called as the first derivative of f. Definitely, kasi f prime is itself first derivative. Pero sabi ko nga kanina, f double prime, we call that as the first derivative of f prime. Okay, so it's just more on the sequence from third to fourth. So ibig sabihin, si third ay first derivative ni second, at si fourth naman ay first derivative ni third, ganyan. Okay? And the function f is sometimes denoted by f. There is 0 here, ibig sabihin siya ang una first derivative. Okay, however, yes, that's not a derivative. F raised to 0, that's not usually used. No, that's not usually. That's why it's sometimes. Now, in other notations, especially when you're reading other books, you might as well encounter the following. Pag nakita natin ang raised to n dito, ibig sabihin, sasabihin niya kung pang ilang derivative ang kukunin mo. Let's say, for example, may 2 dito. Ibig sabihin, get the second derivative. Yan ibig sabihin. Dito naman, ito ang pinakamadalas talaga na ginagamit. D raised to n y over dx raised to n. So, ibig sabihin dito, if you have 3 here, then you have 3 also here. Take note that it's not all about the multiplication process. It's not the multiplication process here. Okay, it's not also exponent. This is just a notation that you have to follow in symbolizing derivatives. Okay, now here naman ito. So just simply observe n. Kung fifth derivative yan, palitan ng n ng 5, ito n ng 5. And this usually hindi siya masyadong ginagamit pag nalampasan mo na ang kapag first derivative it's y prime, pag second derivative ka double prime, pag triple prime. Pero pag raised to 4 o pag fourth, fifth, hindi na siya masyadong ginagamit. So what do we usually use? This notation is usually used. Okay? And the other notation which is f, then you have n here, then x. Yung mga madalas ginagamit. So let's have some examples. So dito, we're going to find f, okay, n. For all n, which are natural numbers starts from 1, 2, 3, or it starts from 0, including 0, okay? Where f of x is equal to x raised to 4 minus 2x raised to 5. So, ibig sabihin nito, kukunin natin ang first, fifth, second, third, fourth, hanggang sa pag-0 na siya. So, let's have the first derivative. The first derivative of that is also denoted by dy over dx, which is equal to, using the power rule, we have 4x cubed minus 10x raised to 4. That is the power rule. So, pagkukunin na natin ang second derivative of that. Okay? Then, kukunin ulit natin ang gagawin natin power rule pa rin ang gagamitin natin. So, we have 12x squared. So, 3 times 2 is 12. So, 3 minus 1 is 2. Minus 40x raised to 3. That is the second derivative. And take note that that can also be written into, so ganyan siya, and dx squared is also the same. And that can also be equated into y double prime. That's also another way. Next, if we're going to get the third derivative of that, the third derivative of that is now equal to, use the power rule, 2 times 12, so we have 24x minus 3 times 40, we have 120x squared. So that is the third derivative. Now getting the fourth derivative, we can just have, okay, ito na yung may enclose na 4, then we have x here. Derivative of 24x is 24, and derivative of 120x squared is negative 240. Kasi 120 times 2 is 140, and negative. That is the fourth derivative. Now we're getting the fifth derivative. Okay, derivative of 24 is 0. So this is minus negative 120, and that is negative 240. I mean 240. And if we're getting to get the derivative of the sixth derivative of that, it will give us 0 now. Because the derivative of constant is already 0. So ibig sabihin nito, so, ibig sabihin, ito ang laging derivative. Ito, 0 lagi ang derivative sa lahat ng n greater than or equal to 6. So, kapag di-differentiate mo ulit, 7th derivative, 0 pa rin ang magiging sagot. Okay, if we try to go back here, the third derivative can also be expressed as d raised to 3y over dx raised to 3. The fourth derivative, we have d4y dx raised to 4, the fifth derivative, d5y over dx raised to 5. But that is not exponent, that's just indication that it's the fifth derivative. Sixth derivative, we have ganyan. Okay, just be very careful on the notation para mas maintindihan ninyo. Okay, ano yan ang pinakamas ginagamit? Okay, mas pinaka-ginagamit ang mga ganitong notations here. The d cube y, dx cube, and others. Basta pakatandaan, if this is 6, that is also 6. Hindi pwede 5 ito, tapos 4 naman ito. It's a violation of the rule. Okay, let's have another example. We're going to get the derivative, the second derivative. So that's indication of the second derivative of f of x equal to 2 raised to x. Let's get the first derivative. The first derivative is 2 raised to x ln of 2. That is the derivative of exponential. Now, getting the second derivative of x would mean, that also means that you are getting the first derivative of 2 raised to x ln of 2. Please do not be confused kasi kukunin mo ang derivative ng 2 raised to x ln of 2, siya din ay ibibigay niya sa iyo ang second derivative. Okay? And that will now be, tandaan nyo na ln of 2 is constant, so ihiwalay ang ln of 2 at i-differentiate natin ang 2 raised to x. So, bibigyan niya tayo na times 2 raised to x ln of 2. At mapapansin ninyo na dalawang ln of 2 here. So, we have 2 raised to x here, ln of 2 squared. Now, this also means that you are now getting the second derivative of y with respect to x. Okay? Let's have the other example. The derivative of first derivative of second x is equal to second x tangent x. Makikita natin dito na nag-product ito, second x tangent x. So kapag kukunin natin ang second derivative niyan, ang mangyayari, we get the derivative of second x, which is second x tangent x. Gagamitin natin yung product rule. Multiply that to the second factor tangent x plus derivative of the second factor tangent x is second squared x. Now multiply that to the first factor second x. Makikita natin na factorable itong two terms by second x. So ilabas ang second x. So tangent x times tangent x here will give us tangent squared x. So this is plus second squared x. Now we have the idea that tangent squared x, tangent squared x plus 1, Pythagorean identity, is second squared x. So ibig sabihin nito, pag kukunin natin ang tangent squared x with respect to second squared x, makakaroon tayo ng second squared x minus 1. So sa madaling salita, pwede natin palitan ng tangent squared x into second squared x minus 1. So we have second x times, replacing tangent squared x by second squared x minus 1. Now combine like terms, so we now have second x of 2 second squared x minus 1. After that, pwede mo nang i-combine, pwede mong i-distribute ang second squared x, so your answer can be 2 second cubed, okay, x minus second x. However, any of these two can be your answer. Now, we're getting the third derivative naman nito, third derivative of sine x. Therefore, we first kunin muna natin ang first derivative niya. So, you have f prime of x, which is equal to dy over dx is equal to cosine x. Okay? So, pag kukunin natin ang second derivative, f double prime of x is equal to another notation. Okay? So, i-differentiate daw natin itong cosine x. So, if we differentiate cosine x with respect to x, it will give us negative sine x. You might as well question me why do I use this one? Kasi ulitin ko, ang derivative ng first derivative ay bibigay niya tayo ng second derivative. Kaya napansin nyo, hindi ako naglagay ng square dito kasi we're now using the first derivative and differentiating first derivative will give us the second derivative. Okay, now our answer will now be, okay, the third derivative is equal to differentiating. Kapag i-differentiate mo ang second derivative, which is negative sine x, ibibigay niya sa iyo ang third derivative. So our answer is negative cosine x. Why? Because derivative of sine x is cosine x. So negative times cosine x will give us negative cosine x. Dito naman, kukunin natin ang fourth derivative of g of x is equal to ln of x. Let's have the first derivative dy over dx is equal to 1 over x. That is the derivative of ln of x. Now getting the second derivative is differentiating the first derivative, 1 over x. So using the rule, rule of differentiating radical that way. We have recall 1 over x raised to n. Differentiate that is equal to negative n over x raised to n plus 1. Please take note of that. So our answer here is negative 1 over x squared. Kasi ang n natin dito is equal to 1. So we're getting the third derivative with respect to x is differentiating the second derivative. The second derivative which is negative 1 over x squared. So that will be negative times, ang n na natin dito is 2. So pwede natin na siyang isulat into negative 2 over x raised to 2 plus 1 using this rule. So our answer will now be 2 over x raised to 3. Now get the fourth derivative. The fourth derivative of this is the first derivative of the third. Okay, pag i-differentiate natin yung third derivative which is 2 over x raised to 3, will now give us separate the constant 2 and use the power, the rule for rational. So we have negative 3 over x raised to 3 plus 1. Again, we keep on recognizing this rule kasi ang n natin dito ay 3. So have negative 3, 3 plus 1 siya using the rule. So ang magiging sagot natin is negative 2. 2 times negative 3 is negative 6 over x raised to 4. So you always go back to the basic rules. Tapos pag sinabi lang naman na higher order derivatives, you just keep on differentiating. Keep on differentiating yung bawat sagot. Okay? Kaya mapapansin nyo dito na from first derivative, differentiate natin ang first derivative will give us the second. Will give us a second derivative. Tapos pag differentiate mo ang second derivative, bibigyan kayo ng third derivative. Tuloy-tuloy lang yan. So pag tinanong sa'yo, what is this fifth derivative of that? Very simple. So getting the fifth derivative is getting the first derivative of the fourth. That is differentiating the fourth derivative, negative 6 over x raised to 4. Will now give us separate the constant and you have negative 5 over x raised to 5. So, saan ko nakuha ang 5 na yan? Kasi we have here n plus 1 and always have negative n on top. So, our answer for the fifth derivative is 30 over x raised to 5. Tuloy-tuloy lang yan. Okay? That's the higher order derivatives. So we try to get the second derivative of g of x that is equal to square root of x. The first derivative f g prime of x is equal to is the same with dy over dx. Using the rule here, pwede ba yan i-rewrite into x raised to 1 half using the power rule of 1 half x raised to 1 half minus 1 is equal to 1 half x raised to negative 1 half. So that is equal to 1 over 2 square root of x. So this is now equal to 1 over 2 square root of x. Now getting the second derivative of that is differentiating the first derivative. So I have to differentiate 1 over 2 square root of x. But take note, 1 over 2 square root of x ay nanggaling siya dito. So 1 half x raised to negative 1 half. So gagawin mo dyan, pwede mo yan gamitin using the power rule 1 half x raised to negative 1 half. So ibaba natin ang negative 1 half. You have negative 1 half times 1 half x raised to negative 1 half. Mag minus 1 ka dito. So magkakaroon ka ng negative 1 half times 1 half x raised to negative 3 over 2. And that will become negative 1 half times negative 1 half is negative 1/4 x raised to negative 3 over 2. And that will now become negative 1 over 4 x raised to 3 over 2 using the power rule. So magiging positive siya pag nilagay mo sa denominator. At i-rewrite mo yan into negative 1 over 4. Pwede kasi ito mag-breakdown ng x raised to 3 over 2 into x times x raised to 1 half. Kasi 1 plus 1 half is 3 over 2. So, mangyayari dyan, ito magsasama. So, we have negative 1 over 4x. At ang x raised to 1 half ay magiging square root of x. Ngayon, pwede mo i-rationalize yan. At ang sagot is negative square root of x over 4. So, square root of x times square root of x, we try to rationalize that. Magiging x lang yan. So, negative square root of x over 4x will be our answer. Okay, so that is negative. And since here, we observe that if we try to go back, square root of x times square root of x is x. So this must be squared. Okay, so this must be 4x squared. So negative square root of x over 4x squared. Or if you would like to have the derivative of y that is equal to tangent x, tapos you're trying to get the third derivative of that tangent x. So, ang gagawin mo dyan, the first derivative, dy over dx, is simply secant squared x. So, pag kukunin mo ang second derivative niyan ni tangent x, so ang sinusolve mo, dinidifferentiate mo ang kanyang first derivative, secant squared x. So, ang gagamitin mo dito is the chain rule. Tandaan mo na pwede mo yan i-rewrite into secant x square. So you're going to get use the generalized power rule. So we have 2, bring down 2 times secant x, 2 minus 1. And the derivative of secant x is secant x tangent x. So i-multiply natin yan. Therefore, ang magiging second derivative natin is 2 secant x times secant x tangent x combined. So we have 2 secant squared x tangent x. Ngayon, pag tinanong, we're now ready to get the third derivative. Ang third derivative natin is now differentiating the second derivative, which is 2 secant squared x tangent x. Ang gagamitin natin dito is the product rule. I-separate natin yung constant na 2. So, meron tayong 2 times derivative of the first factor, secant squared x, is actually, ito na siya. Okay, so you have 2 secant squared x tangent x times the second factor tangent x plus the derivative of the second factor is secant squared x times the first factor secant squared x. So, magiging sagot natin dyan, we have combine like terms, combine the constant, 2 times 2 is 4. 4 secant squared x tangent squared x, kasi we're tangent x times tangent x is tangent squared x, plus secant, then that's raised to 4 x. So ganun pa rin na nangyayari. You are using the chain rule, you are using other rules of differentiation. Just keep on differentiating. That's what we call the higher order derivatives.